Good morning students, welcome back to third session. I am Vinod Sijjanavar, Assistant Professor, Department of Computer Science. So our subject Computer Fundamentals for BA, BSc and BCom third semester students, which will come under Vijayanagara Shri Krishna Devaraya University, Ballari. So today's topic is the generation, that is computer generation. Before going on to the computer generation, we will first revise or recap the first two sessions. That is, in the first two sessions we have learnt about what is computer, definition of computer and some of the early computers with examples, right? So those are the computers which were, that is, those are the computing device which were helped to develop the today's computer. So now we will categorize the generation based on the development occurred. ಅಂದರೆ ಯಾವ ಥರ ಡೆವಲಪ್ಮೆಂಟ್ ಆಗ್ತಾ ಬಂತಲ್ಲ, ಹೊಸ ಟೆಕ್ನಾಲಜಿ ಇನ್ಕ್ಲೂಡ್ ಆಗ್ತಾ ಬಂತಲ್ಲ, ಸೊ ಆ ಥರ ನಾವು ಜನ್ರೇಷನ್ನ ನಾವು ಡಿವೈಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ ಅದರಲ್ಲಿ ನಾವು ಜನ್ರೇಷನ್ ಬಂದು 5 types of generations ಇರುತ್ತೆ. So we will see that generations now. So topic is generation of computer. So ಈ ಕ್ಲಾಸಿನ ಉದ್ದೇಶ ಅಂದರೆ ಈ ಸೆಷನ್ನ ಉದ್ದೇಶ ಏನಂತಂದರೆ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಡಿಫ್ರೆಂಟ್ ಜನರೇಷನ್ಸ್ ಆಫ್ ಕಂಪ್ಯೂಟರ್. ಅಂದರೆ ಎಷ್ಟು ಜನ್ರೇಷನ್ ಇದಾವಲ್ಲ, ಆ ಈ ಜನ್ರೇಷನಲ್ಲಿ ಏನೇನಾಗಿದೆ, ಹೆಂಗೆ ಬಂದಿದೆ, ಅಂದರೆ ಯಾವುದಾದ್ರು ಹೊಸ ಟೆಕ್ನಾಲಜಿ ಇನ್ಕ್ಲೂಡ್ ಆಗಿದೆ, ಈಚ್ ಜನರೇಷನ್ ವೈಸ್ we will see now. Now session outcome ಅಂತಂದರೆ in this session you will able to understand, ಅಂದರೆ ನೀವು able to understand different generations, ಅಂದರೆ different types of generation ಯಾವ್ಯಾವ ಇದು ಅನ್ನೋದನ್ನು ನೋಡ್ತೀರಿ. ಪ್ಲಸ್ ಅದ್ರ ಜೊತೆ you need to differentiate between the, ಅಂದರೆ ನೀವು ಎಲ್ಲ ಜನ್ರೇಷನ್ ಮಧ್ಯೆ ವ್ಯತ್ಯಾಸವನ್ನು ನೋಡ್ಕೋಬೇಕು. ಅಂದರೆ ಆ ಥರ ನೀವು ಯಾವುದೇ ಜನ್ರೇಷನ್ ಕೊಟ್ಟರು ಆ ಜನ್ರೇಷನ್ದ ಫೀಚರ್ಸ್ ಪ್ಲಸ್ ಅದರಲ್ಲಿ ಏನಿತ್ತು ಅನ್ನೋದು ನೀವು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡೋದನ್ನ ಕಲ್ತ್ಕೋಬೇಕು, ಅಂದರೆ ಕಲ್ಕೊತೀರಿ ಈ ಸೆಷನ್ ಮುಗಿದ ಮೇಲೆ, ರೈಟ್? ಸೊ ನಾವು ವಿ ವಿಲ್ ಮೂವ್ ಆನ್ ಟು ದ ಡೈರೆಕ್ಟ್ಲಿ ಟಾಪಿಕ್, ದಟ್ ಈಸ್ ಜನರೇಷನ್ಸ್. ಫಸ್ಟ್ ಜನರೇಷನ್ ವಿಚ್ ವಾಸ್ evolved in 1945 to 1955. ಅಂದರೆ ಫಸ್ಟ್ ಜನರೇಷನ್ ಬಂದು 1945ರಿಂದ 1955ರಲ್ಲಿ ಬಂತು. ಸೊ ಈ ಫಸ್ಟ್ ಜನ್ರೇಷನಲ್ಲಿ ಏನೇನು ಯೂಸ್ ಮಾಡಿದ್ರು ಅಂತಂದರೆ, ಫಸ್ಟ್ ಜನ್ರೇಷನಲ್ಲಿ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಯೂಸ್ ಮಾಡಿದ್ರು. 2 materials, ದಟ್ ಈಸ್ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಫಾರ್ ಸರ್ಕ್ಯೂಟ್ರಿ ಆ್ಯಂಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡ್ರಮ್ಸ್ ಫಾರ್ ಮೆಮರಿ. ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ಸ್ ಫಾರ್ ಸರ್ಕ್ಯೂಟ್ರಿ ಅಂತಂದರೆ ಸರ್ಕ್ಯೂಟ್ ಕನೆಕ್ಷನ್ಸ್, ಅಂದರೆ ಇನ್ಪುಟ್ ಹೆಂಗೆ ತೊಗೋಬೇಕು, ಔಟ್ಪುಟ್ ಯಾವ ಥರ ಡಿಸ್ಪ್ಲೇ ಮಾಡಬೇಕು, ಆಮೇಲೆ ಸ್ಟೋರ್ ಹೆಂಗೆ ಮಾಡಬೇಕು, ಸೊ ಆ ಥರ ಮಾಡೋದಕ್ಕೆ ಒಂದು ಸರ್ಕ್ಯೂಟ್ರಿ ಬೇಕು ನಮಗೆ. ಸೊ ಆ ಸರ್ಕ್ಯೂಟ್ರಿ ಪ್ಲಸ್ ಆ ಸರ್ಕ್ಯೂಟ್ರಿಂದ ಏನು ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ, ವಿ ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಅರ್ಥಮೆಟಿಕ್ ಆಪ್ರೇಷನ್ಸ್ ಆ್ಯಸ್ ವೆಲ್ ಆಸ್ ಸಮ್ ಅದರ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್, ರೈಟ್? ಆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡೋದಕ್ಕೆ ವಿ ನೀಡ್ ಸಮ್ ಸರ್ಕ್ಯೂಟ್ರಿ. ಸೊ ಆ ಸರ್ಕ್ಯೂಟ್ರಿ ಎದರಿಂದ ತಯಾರು ಮಾಡ್ತಾರೆ ಅಂತಂದರೆ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ಸ್. ಸೊ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಬಂದು ಫಾರ್ ಸರ್ಕ್ಯೂಟ್ರಿ ಡೆವಲಪ್ ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡಿದ್ರು. ಪ್ಲಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡ್ರಮ್ಸ್ನ ಯೂಸ್ ಮಾಡಿ ಮೆಮ್ರಿಗೆ ಯೂಸ್ ಮಾಡೋದು. ಮೆಮ್ರಿಗೆ ಏನಂತಂತಂದರೆ, ಇವಾಗ ನೀವೇನಾದರೂ ಇನ್ಪುಟ್ ಕೊಟ್ಟರೆ ಆ ಇನ್ಪುಟ್ ಬಂದು ಕಂಪ್ಯೂಟ್ರಲ್ಲಿ ಸ್ಟೋರ್ ಆಗುತ್ತಲ್ಲ, ಸೊ ಸ್ಟೋರ್ ಆಗೋದಕ್ಕೆ ನಾವೇನಂತೀವಿ, ಮೆಮೊರಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಆ ಮೆಮೊರಿಯಲ್ಲಿ ಸ್ಟೋರ್ ಆಗೋದಕ್ಕೆ ವಿ ಹ್ಯಾವ್ ಯೂಸ್ಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡ್ರಮ್ಸ್. ಸೊ ಡೋಂಟ್ ವರಿ ಅಬೌಟ್ ದ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ಸ್ ಆ್ಯಂಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡ್ರಮ್ ಇನ್ ಡೀಟೇಲ್. ಅಂದರೆ ಇನ್ ಡೀಟೇಲ್ ಏನು ತಿಳ್ಕೊಳ್ಳೋದು ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಬರೀ ನೀವೇನಂತ ತಿಳ್ಕೊಬೇಕಂತಂದರೆ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡಿದ್ರು ಪ್ಲಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡ್ರಮ್ಸ್ ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡೋರು ಅಂತ ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ಸಾಕು. ನೆಕ್ಸ್ಟ್, ದ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ಸ್ ಇನ್ ಪ್ಲೇಸ್ ಆಫ್ ರಿಲೇ ಮೀನ್ಸ್ ಸ್ಟೋರಿಂಗ್ ದ ಡಾಟಾ ಇನ್ ದ ಮೆಮರಿ ಆ್ಯಂಡ್ ದ ಯೂಸ್ ಆಫ್ ಸ್ಟೋರ್ಡ್ ಪ್ರೋಗ್ರಾಮ್ ಕಾನ್ಸೆಪ್ಟ್. ಸೊ ನಾವು ಅರ್ಲಿ ಕಂಪ್ಯೂಟರ್ಸಲ್ಲಿ ನೋಡಿದ ಹಾಗೆ ಸ್ಟೋರ್ಡ್ ಪ್ರೋಗ್ರಾಮ್ ಕಾನ್ಸೆಪ್ಟ್ ಇತ್ತಲ್ಲ. ಸ್ಟೋರ್ಡ್ ಪ್ರೋಗ್ರಾಮ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಂತಂದರೆ ಒಂದು ಪ್ರೋಗ್ರಾಮ್ ಬರೀತಾರೆ, ಆ ಪ್ರೋಗ್ರಾಮ್ನ ಕಂಪ್ಯೂಟ್ರಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಯಾವುದೇ ಇನ್ಪುಟ್ ಕೊಟ್ಟರೆ ಆ ಪ್ರೋಗ್ರಾಮ್ ಥ್ರೂ ಅದು ರನ್ ಆಗ್ತಾ ಹೋಗಿ ನಮಗೆ ರಿಸಲ್ಟ್ ಕೊಡುತ್ತೆ. ಸೊ ಫಾರ್ ದ್ಯಾಟ್ ರೀಸನ್ ದೇ ಯೂಸ್ ದ ಸ್ಟೋರ್ಡ್ ಪ್ರೋಗ್ರಾಮ್ ಕಾನ್ಸೆಪ್ಟ್. ಅಂದರೆ ಒಂದು ಪ್ರೋಗ್ರಾಮ್ ಬರೆದು ಆ ಕಂಪ್ಯೂಟ್ರಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡಿಬಿಡ್ತಾರೆ. ಸೊ ಫಾರ್ ದ್ಯಾಟ್ ರೀಸನ್ ಇಟ್ ಈಸ್ ಅ ಸ್ಟೋರ್ಡ್ program concept, right? So it was used in the first generation computer. Next, it requires 3.5 kV of electricity per day to keep the vacuum tube running. ಅಂದರೆ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ನೀವು ರನ್ ಆಗಬೇಕಂತಂದರೆ ಅಥವಾ ಅದು ನಡಿಬೇಕಂತಂದರೆ ವಿ ನೀಡ್ ಅ 3.5 ಕಿಲೋ ವಾಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪರ್ ಡೇ. ಅಂದರೆ ಒಂದು ದಿನಕ್ಕೆ ನಮಗೆ 3.5 ಕಿಲೋ ವಾಟ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಬೇಕು. ಏನಕ್ಕೆ ಅಂತಂದರೆ ಟು ರನ್ ದ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಸರ್ಕ್ಯೂಟ್ರಿ. ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಸರ್ಕ್ಯೂಟ್ರಿ ಇರುತ್ತಲ್ಲ ಅದನ್ನ ರನ್ ಮಾಡೋದಕ್ಕೆ they have used. So this is about the first generation. You can see the picture here. He is using the some of the circuitry board to store the data, and these are the vacuum tubes. So now we will see the some of the features. Andre ella features include ಮಾಡೋದು ಬೇಡ. Some of the features which are important for the first generation. That is, these are the features. You can see here vacuum tubes. So this is how they have arranged to create a circuitry. ಅಂದರೆ ಈ ಥರ ಅರೇಂಜ್ ಮಾಡಿ ಅದನ್ನ ಸರ್ಕ್ಯೂಟ್ರಿ ಮಾಡೋದಕ್ಕೆ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ಸ್ ವೇರ್ ಯೂಸ್ಡ್. ನೆಕ್ಸ್ಟ್ ಫೀಚರ್ಸಲ್ಲಿ ಬಂದ್ಬಿಟ್ಟು ಫಸ್ಟ್ ಈಸ್ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಟೆಕ್ನಾಲಜಿ. ಅಂದರೆ ಫಸ್ಟ್ ಆ್ಯಸ್ ವಿ ಹ್ಯಾವ್ ಸೀನ್ ಇನ್ ದ ಫಸ್ಟ್ ಸ್ಲೈಡ್, ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ಸ್ ಆರ್ ಯೂಸ್ಡ್ ಫಾರ್ ಸರ್ಕ್ಯೂಟ್ರಿ. ಸೊ ಇಟ್ ಯೂಸಸ್ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಟೆಕ್ನಾಲಜಿ. ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಫೀಚರ್ ಈಸ್ ಅನ್ರಿಲಯಬಲ್. ಅನ್ರಿಲಯಬಲ್ ಅಂತ ಯಾಕೆ ಹೇಳ್ತೀವಿ ಅಂತಂದರೆ, as we have seen, vacuum tubes are made up of glasses. ಅಂದರೆ ಗ್ಲಾಸ್ ಮಟೀರಿಯಲ್ ಅಥವಾ ಫಿಲಮೆಂಟ್ ಇಂದ ಮಾಡಿರ್ತಾರೆ. ಸೊ ಅದು ಹೀಟ್ ಆಗಿ ಒಡೆಯೋ ಚಾನ್ಸಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅಂದರೆ ಬರ್ಸ್ಟ್ ಆಗೋ ಚಾನ್ಸಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಫಾರ್ ದ್ಯಾಟ್ ರೀಸನ್ ವಿ ಕೆನಾಟ್ ರಿಲೈ ಆನ್ ದ ಸರ್ಕ್ಯೂಟ್ರಿ, ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಸರ್ಕ್ಯೂಟ್ರಿ, ಬಿಕಾಸ್ ದೇ ವಿಲ್ ಗೆಟ್ ಹೀಟೆಡ್ ಆ್ಯಂಡ್ ದ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ಸ್ ಮೇ ಗೆಟ್ ಬರ್ಸ್ಟ್ ಆ್ಯಂಡ್ ಸರ್ಕ್ಯೂಟ್ರಿ ಮೇ ಬಿ ಡೆಸ್ಟ್ರಾಯ್ಡ್. ಅಂದರೆ ಈ ಥರ ಆಗೋ ರೀಸನ್ಗೆ we cannot rely on the computer. Because of that it is unreliable. Next, supported machine language only. ಬೇರೆ ಯಾವುದೇ ಥರ ಲ್ಯಾಂಗ್ವೇಜ್ನ ಅದು ಸಪೋರ್ಟ್ ಮಾಡಲ್ಲ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅಸೆಂಬ್ಲಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಅಥವಾ ಸ್ಟೋರ್ಡ್ ಪ್ರೋಗ್ರಾಮ್ ಅದೆಲ್ಲ ಲ್ಯಾಂಗ್ವೇಜ್ ಇರುತ್ತಲ್ಲ, ಸೊ ಆ ಲ್ಯಾಂಗ್ವೇಜನ್ನು ಇದು ಸಪೋರ್ಟ್ ಮಾಡಲ್ಲ. ಇಟ್ ವಿಲ್ ಸಪೋರ್ಟ್ ಓನ್ಲಿ ಮಷೀನ್ ಲ್ಯಾಂಗ್ವೇಜ್, ರೈಟ್. ಇಟ್ ವಾಸ್ ವೆರಿ ಎಕ್ಸ್ಪೆನ್ಸಿವ್. ಯಾಕಂತಂದರೆ these vacuum tubes were very expensive at that time of the moment. ಅಂದರೆ ಆವಾಗ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಭಾಳ ಕಾಸ್ಟ್ಲಿ ಇದು. ಸೊ ಫಾರ್ ದ್ಯಾಟ್ ರೀಸನ್ ದ ಮೇಕಿಂಗ್ ಆಫ್ ಸರ್ಕ್ಯೂಟ್ರಿ ಈಸ್ ವೆರಿ ಎಕ್ಸ್ಪೆನ್ಸಿವ್. ನೆಕ್ಸ್ಟ್, generate lots of heat, as we have seen earlier. As these are vacuum tubes ಇರೋದ್ರಿಂದ that will light ಹತ್ತವಲ್ಲ, ಆ ರೀಸನ್ಗೆ it will get heated and the circuitry also get heated. For that reason it generates lot of heat. Next, slow input and slow output. As this is the first generation computers, so the input and output is not that easy to make the circuitry. So for that reason it is very slow output and input devices, because it was using the magnetic drums. Magnetic drums need to be rotated. For that reason input and output will be very slow. Next, huge size, as making the circuitry take a lot of space. ಅಂದರೆ ಸರ್ಕ್ಯೂಟ್ರಿ ಮಾಡಬೇಕಂತಂದರೆ it required a lot of space to make the circuitry. For that reason it acquires a huge amount of space in one room. So you can imagine one computer will be placed in one whole room in the first generation. So it will acquire that much of space. For that reason it is a huge size. Next, it needs AC, because as it is generating lot of heat it needs a AC. Next, it is non-portable ಅಂತಂದ್ರೆ we cannot take the computer from one place to another place, because as it is a very huge circuitry, in transportation it may get damaged because of that very large space. So we cannot port or we cannot transfer the whole computer from one place to another place very easily. For that reason it is non-portable. Last one, consume lot of electricity. As it runs on vacuum tubes it consumes lot of electricity. So the feature is consumed lot of electricity. So these are the some of the features of first generation. Next we will see some of the examples of first generation. As we have seen this in the previous session, ENIAC, EDVAC, UNIVAC and IBM. These are the three first computers were used in the first generation. So these will come under first generation. Next. Now we will move on to the second generation, that will be starting from 1956 to 1963. So in the first generation we have used vacuum tubes. In the second generation we are going to use the transistors. You can see this. These are transistors and these are very cheaper as compared to the vacuum tubes, and these are very small. You can see here, cheaper, consumed less power, more compact in size, andre size alli very small and more reliable, because these will not get heated and will not get burst. Andre vacuum tara ivu heat agi burst agala. For that reason it is very reliable and faster than first generation, as compared to the vacuum tubes. So in this generation, magnetic cores. In the first generation, magnetic drums were used, but in this generation we are using magnetic cores were used as a primary memory, and magnetic tapes and magnetic disk as a secondary storage device. So concept of primary memory and secondary memory were introduced in the second generation. So for that reason they have divided the memory into two types, that is primary and secondary memory. So primary memory will be using magnetic cores and secondary memory will be using magnetic tape and magnetic disk for storage purpose. So this is the concept of second generation. In this one, main technology is using of transistors instead of vacuum tube in the second generation. Now we will see the some of the features. Andre ondistu features nodonante. So features of second generation, as you can see here, it is acquiring small space as compared to the vacuum tube technology, because it was using very huge space. Now first and foremost feature is use of transistors. So in the first generation we were using vacuum tube use ಮಾಡ್ತಾ ಇದೀವಿ. So in the second generation ಅಲ್ಲಿ ನಾವು transistors ನ use ಮಾಡಿದ್ವಿ. So reliable as compared to the first generation computers. ಯಾಕೆ ರಿಲಯಬಲ್ ಅಂತಂತಂದ್ರೆ ಫಸ್ಟ್ ಜನರೇಷನ್ ಅಲ್ಲಿ ನಾವು ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ಸ್ ಇರೋದ್ರಿಂದ, ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್ಸ್ ಮೇ ಗೆಟ್ ಬರ್ಸ್ಟ್, ಅಂದರೆ ಅದು ಮಧ್ಯದಲ್ಲಿ ಬರ್ಸ್ಟ್ ಆಗಿ ಸರ್ಕ್ಯೂಟ್ನ ಹಾಳು ಮಾಡ್ಬೋದು. ಫಾರ್ ದ್ಯಾಟ್ ರೀಸನ್ ಇಟ್ ವಾಸ್ ನಾಟ್ ದ್ಯಾಟ್ ರಿಲಯಬಲ್. ಬಟ್ ಆ್ಯಸ್ ಕಂಪೇರ್ಡ್ ಟು ದ ಸೆಕೆಂಡ್ ಜನರೇಷನ್ ನಾವು ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ಇಟ್ ಈಸ್ ವೆರಿ ಸ್ಮಾಲ್ ಇನ್ ಸೈಜ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ವೆರಿ ರಿಲಯಬಲ್, because it will not get bursted and it will not destroy the circuitry. For that reason it is reliable. Next, smaller as compared to the first generation computer. As we have seen, the transistors are very smaller than vacuum tubes. Next, it consumes less electricity as it is smaller in size and reliable, and it uses transistors, so electricity will be very less, means used very less. Next, faster than first generation computers. So faster means in terms of operations. As we have seen in the vacuum tube first generation, it was consuming very high amount of electricity as well as size. For that reason the operations were very slow in that. But as in case of second generation, we were using transistors and it was consuming less electricity and reliable, smaller in size. For that reason it is faster as compared to the first generation computers. Still AC is needed, because transistors also get heated and it may cause the destroying of circuitry. For that reason we still use the AC for second generation computers also. And in this generation it will support machine as well as assembly language. In the first generation it is supporting only machine language, but in case of second generation it is supporting machine as well as assembly language also. So these are the features of second generation. Hope you understood. Next we will see some examples of second generation. So examples are IBM 1620, IBM 7094, CDC 1604, CDC 3600, UNIVAC 1108. These are the examples of second generation, and these are some of the pictures which include the second generation computers like IBM and CDC UNIVAC. You can see here, these are the pictures. So now we will move on to the third generation. So third generation was started in the year 1964 and 1974. So in the first generation we have used vacuum tubes, in the second generation transistors. Now in the third generation we are going to use the integrated circuits. In the third generation we are going to use integrated circuits, that is in short ICs. You can see here, this is the integrated circuit. So why it is called integrated circuits? Right, the single IC has many transistors, resistors, capacitors along with the associated circuitry. So in the second generation we are using the only transistors, but in the third generation we are going to use the integrated circuits. Integrated means it is a combination or it is a compact circuitry which consists of resistors, transistors and capacitors. These three were used to form the circuitry, right? In the first generation, to form the circuitry we used the vacuum tubes. In the second generation, to form the circuitry we used only transistors, but in case of third generation we are going to use the integrated circuits, that is consisting of transistors, resistors and capacitors to form the circuitry, right? So integrated solid state circuitry improved the secondary storage device, and new input output devices were most important advancement in the generation. As the circuitry becoming very smaller in size, so the input and output as well as the storing of ಅಂದರೆ ನಾವು ಯೂಸರ್ ಏನು ಇನ್ಪುಟ್ ಕೊಡ್ತಾರಲ್ಲ ಅದು ಪ್ಲಸ್ ಅದರಿಂದ ನಾವು ಒಂದು ಸರ್ಕ್ಯೂಟ್ರಿ ಮಾಡಿ ಅದನ್ನ ಪ್ರಾಸೆಸ್ ಮಾಡಿ ಔಟ್ಪುಟ್ ತೋರಿಸ್ತೀವಲ್ಲ, ಸೊ ಅದು ಇಂಪ್ರೂವ್ಮೆಂಟ್ ಆಯಿತು ಬಿಕಾಸ್ ಆಫ್ this compact circuitry. And as well as not only input and output, we have improved the storage of any data or stored programs. So this is what the third generation means. So we will see some of the features of third generation. So these are the features. You can see here, this is the integrated circuitry which will be consisting of transistors, resistors and capacitors. So this whole circuitry is called a IC, that is integrated circuit. Next features, first is ICs were used, and this is more reliable as it is a integrated circuit. It consisting of all the transistors, capacitors as well as resistors. So it is becoming very small and reliable. So these are more reliable as compared to the first and second generation. Next, smaller in size as compared to the first, second and third. It is very smaller because it consisting of all the features in a very smaller area. Next, generates less heats as it is a combination of all the three components, that is resistor, transistors and capacitors. It generates very less heat and it is very compact in nature. Next, it is faster as compared to the first and second generation, and less maintenance is required. Why less maintenance? In case of first generation we need a continuous maintenance to see whether the vacuum tubes were bursted or not, and in case of third generation, second generation also, we need to keep track of each transistors in the circuitry. Each transistor needs to be maintained, but in case of third generation, less maintenance is needed, because the once the circuit is not working, we can remove the integrated circuit, particular integrated circuit, and replace with a new one. So for that reason, less maintenance is required in case of third generation. Next is still costly, because we were using three components in a IC, that is transistor, capacitor and resistors were used, so it is still costlier, and AC is still needed because IC also get heated. For that reason, AC is still needed. Next, consumed less electricity, as we are using integrated circuit, so it will consume less electricity as compared to the first and second generation. Next, it supports high level language. It supports high level language in case of first and second generation. In first generation, it was supporting only machine language. In the second generation, it was supporting machine as well as assembly language. In case of third generation, it supports high level language. Right? So these are the features of third generation. Now we will see the examples of third generation. Examples are IBM 360 series, Honeywell 6000 series, PDP means personal data processor. Next, IBM 370 bar 168, TDC 316. You can see this. These are the some of the third generation computers. Now we will move on to the next generation, that is fourth generation. So fourth generation was started in 1971 to 1980. So in the first generation we have used vacuum tubes, second generation transistors, third generation integrated circuits. But in case of fourth generation, we were using very large scale integration, that is VLSI circuits. VLSI circuits were used in the fourth generation. So VLSI circuits having about 5,000 transistors and other circuit elements and their associated circuits on a single chip made it possible to have microcomputers of fourth generation. So fourth generation ಏನು introduce ಆಯ್ತು ಅಂತಂದ್ರೆ VLSI, that is very large scale integration, that is VLSI circuits were used. In this one, almost 5,000 transistors and other circuitry elements like capacitors and resistors were associated in this single chip. You can see this single chip. In this single chip, all these 5,000 transistors, resistors, capacitors and other circuitry elements were embedded in a small compact chip like element called very large scale integration circuit. So in this one, it using very small very large scale integrated circuits, and it was introduced in the fourth generation. Right? So we will see some of the features of fourth generation. So fourth generation were using VLSI technology. In the first generation, vacuum tubes, second generation transistors, third generation integrated circuits, fourth generation using VLSI technology. And third one, second feature, very cheap as compared to the first three generations. These VLSI circuits were very cheap. Next, portable and reliable. First three generations were non-portable because it will be consuming very huge space. So for that reason, we cannot take the computer from one place to another place, because circuitry may get destroyed or it may get distracted. For that reason, portability is not possible in case of first three generation. In the fourth generation, portability is very easy and it was very reliable, as the VLSI chips were very small and very cheap, and it is very consuming very less amount of electricity. For that reason, it is very reliable and we no need to worry about the circuitry destroying or it may get destroyed because of the heat, right? So next is very small in size. We have seen, as the chip is, we have seen this chip, it is very small. Next, pipeline processing. Pipeline processing means, in case of first three generations, if the input is given, then it will be processing one input or one process at a time. But in case of fourth generation, we can process multiple operations at a time, and it will be pipelined, means process will be pipelined one after the other. Next, no AC is required. Now AC is removed, but for first three generations we required AC. Next is concept of internet was introduced. So for sending email, for receiving email, or for connecting any other purpose, or we need a internet, that internet concept was introduced in the fourth generation computers. Next, great development in the field of network. As the computers were very small in size, and these can be portable from one place to another place, so networking of computers means we can network computers together to work together. So for that reason, great development were happened in the field of networks in case of fourth generations, and computers become very easy. As the cost and the size of the computer were reduced, the price also reduced to very minimal amount. For that reason, any user or any normal person can buy that computer very easily. So in the fourth generation, computers were available to all the people which were affordable. Means we can tell that fourth generation computers were very reliable and very cheap, so that we can buy the computers, and these were very affordable, right? We will see some of the examples now. Examples were DCE 10 star 1000, PDP 11, Cry 1 and Cry XMP. These were also the examples of fourth generations, right? Now we will move on to the last and final generation, that is fifth generation. This is the final generation, right? It will be present and beyond, means final generation will be continuing until the next generation also, means final fifth one is a final generation, right? In this one we are going to use the artificial intelligence. First generation, vacuum tubes were used. Second generation, transistors. Third generation, ICs. Fourth generation, VLSI. And final fifth generation were using artificial intelligence. So artificial intelligence is the branch of computer science concerning with the making computers behaving like human. Means you can say that computers will work as the human works as alike. Means now human ಯಾವ ಥರ ವರ್ಕ್ ಮಾಡ್ತೀವಲ್ಲ, same work will be shared and done by the computers using the artificial intelligence. Means ನಾವು ಯಾವುದ್ಯಾವ್ದು ಹ್ಯೂಮನ್ ಮಾಡೋ ಕೆಲಸನ ಅದು ಕಂಪ್ಯೂಟರ್ ಮಿನಿಮಲ್ ಮಾಡ್ತಾ ಮಾಡ್ತಾ ಬರ್ತಾ ಇದೆ. ಮೀನ್ಸ್ ಆಟೋಮೇಷನ್ಸ್ ವರ್ ಇನ್ಕ್ಲೂಡೆಡ್ ಫ್ರಮ್ ದಿಸ್ ಜನರೇಷನ್ಸ್. ಅಂದರೆ ಯಾವುದೇ ಹ್ಯೂಮನ್ ರಿಲಯಬಲ್ ವರ್ಕ್ನ ಆಟೋಮೇಷನ್ ಮಾಡಿ ಕಂಪ್ಯೂಟರ್ಸ್ ವೇರ್ ಇಂಟ್ರಡ್ಯೂಸ್ಡ್ to make the work lesser and faster and very easily without any delays, right? So for that reason, artificial intelligence were introduced in the fifth generation. The term was introduced by John McCarthy. Means the fifth generation artificial intelligence that term was given by the John McCarthy by Massachusetts Institute of Technology. Next, we will see the features of fifth generation. Development of storage technology, right? So as the fifth generation is becoming very easy, so we can now concentrate on storage technology, how to store and make the as small as we need. Means we can store n number of or bunch of data in a smaller space that requires very small amount of size, and means in terms of space. For that reason development were made of storage technology. Next, advancement in networking technology. As the computers were becoming very fast and very cheap, and the networking technology also becoming very advanced. Next, we can see as cheaper, faster and more reliable as compared to the first four generation. Development of supercomputers. Nowadays in all the computers were very, means computers are very normal computers. Supercomputers were developed in case of fifth generation for the purpose of storing satellite data or some scientific calculations. For that reason we have used supercomputers. Concept of parallel processing, as I have explained the parallel processing in the previous one, means process will be parallelly running one after the other. No means we can run multiple processes at a time. Next, development of robotics. Robots were introduced to assist the human. Means humans were day by day replacing by the robots. Next, to make the computer solve highly complex problem that require expertise, knowledge and reasonable experiment. This means, this whole sentence means, ಅಂದರೆ ಯಾವುದೇ ಒಂದು ಸೈಂಟಿಫಿಕ್ ಪ್ರಾಬ್ಲಮ್ ಇತ್ತಂತಂದರೆ means which will be very difficult for the human to solve at the faster rate. ಅಂದರೆ ಬೇಗ ಸಾಲ್ವ್ ಮಾಡೋಕ್ಕಾಗಿಲ್ಲ ಅಂತಂದರೆ ಅಂಥ ಪ್ರಾಬ್ಲಮ್ಸ್ ನಾವು ಕಂಪ್ಯೂಟರ್ಗೆ ಇನ್ಪುಟ್ ಕೊಟ್ಟರೆ ಇಟ್ ವಿಲ್ ಸಾಲ್ವ್ ಆ್ಯಂಡ್ ಗಿವ್, ಪ್ರೊವೈಡೆಡ್ ಆ ಪ್ರಾಬ್ಲಮ್ಗೆ ಅದು ಸಾಲ್ವ್ ಮಾಡೋ ಥರ ಪ್ರೋಗ್ರಾಮ್ ಅದರಲ್ಲಿ ಇರಬೇಕು. ಸೊ ಆ ಥರ ಅದರಲ್ಲಿ ಪ್ರೋಗ್ರಾಮ್ ಇತ್ತಂತಂದರೆ ಇಟ್ ವಿಲ್ ಗಿವ್ ಇನ್ ದ ಫ್ರ್ಯಾಕ್ಷನ್ ಆಫ್ ಸೆಕೆಂಡ್ಸ್. ಮೀನ್ಸ್ ಫಾರ್ ಅಸ್ ಹ್ಯೂಮನ್ it requires a lot of time to calculate something, but for the computer, once you have developed some program or some process in it, it will make use of that process and give the result very faster. Next, able to translate foreign languages. Means as we have seen, many languages were translated, and programming language also translating from low level languages to high level language, so that human can understand the computer language. So these were some of the development and some of the features of the fifth generation which were currently running. So now we will see some of the examples of that. That is, artificial intelligence include gaming. As we have seen, gaming means using the graphics. We can able to play with the computers. So that gaming programs were written using the artificial intelligence, so that it will think as the human thinks. Means for example, you may be seeing this or you may be played this game in the book, right? Having thinking power as equivalent to human, and it will think based on your input and it will give you the result. Based on that, the gaming applications were built. Next, you can see this robot. Human will get tired and he may make some mistake, but computer will not make the mistake unless and until you have inputted correct program in it. ಅಂದರೆ ಅದಕ್ಕೆ ನೀವು ಕರೆಕ್ಟ್ ಪ್ರೋಗ್ರಾಮ್ ಇನ್ಬಿಲ್ಟ್ ಅಲ್ಲಿ ಹಾಕಿದ್ರಿ ಅಂತಂದರೆ, ಅದು ಪ್ರೋಗ್ರಾಮ್ ಇನ್ಪುಟ್ ಮಾಡಿದ್ರಿ ಅಂತಂದರೆ, ಇಟ್ ವಿಲ್ ವರ್ಕ್ ಆಸ್ ಫಾಸ್ಟ್ ಆಸ್ humans. You cannot imagine, means human will not make that fast as the robot will make. So for that reason, robots are being replacing the humans. So this is how the fifth generation example were working now. So this completes your fifth, means 5 generations. So in this session we have learned about the history of computers, and also we have learned some of the example of each generation. Means we have learned some generation, 5 generation with example, right? So now we will conclude the session here and we will go to the quiz session. So, first question, first generation uses option A transistors, option B VLSI, option C vacuum tube, option D integrated circuit. Any guesses? Answer is vacuum tube. As I was saying, first ever generation were used only vacuum tube. Next question. Second generation uses option A transistors, option B vacuum tube, option C VLSI, option D integrated circuits. Any guesses? Yes, second generation were using transistors. Now third generation uses option A transistors, option B vacuum tube, option C VLSI, option D integrated circuits. Any guesses? So answer is integrated circuits, nothing but ICs. Right? Next question. Fourth generation uses option A transistors, option B VLSI, option C vacuum tube, option D integrated circuits. Any answer? Answer is VLSI. Right? Very large scale integrated circuits. Right? Next question. Fifth generation uses option A transistors, option B VLSI, option C artificial intelligence, option D integrated circuits. Any guesses? Right. Answer is artificial intelligence. Last and final generation uses the artificial intelligence. So this concludes the generation part of this session. Now, if you have any doubt or you want to read more about the generation, please refer PV Kotur and Computer Concept and C Programming by PV Kotur and Computer Fundamentals by Halkar Rachappa book. You can refer any of the book for more detail. Thank you for your patience. Thank you for watching, and be safe in home. Learn digitally. Thank you.